Then one standard deviation of the mean.
68.
Okay, what percent falls within 2?
95%.
And within 3?
99.7.
And if you didn't memorize those 3 things, you need to. 68, 95, and 99.7. But what words I didn't say at the beginning that I should have said is that rule only works for what kind of data?
Symmetrical.
So it's got to say words like that me and Jackson are scared of. Standardized, normal, symmetrical. It's got to say something like that, or else we can't do this. Okay, so yesterday we skipped this hard one because we decided, hey, let's practice some easier ones first before we go crazy. I don't know about you, but I was reading your textbook. It's actually a good read, so if you get confused on something, you could definitely ask it. In fact, it explains the empirical rule, the 68, 95, 99.7. It explains it on, or at least on my book, it's page 114. So if you're confused about that rule, see page 114. It explains it really well. And it applies to why it only works for normal distributions. Now, for those of you who want to just be a smarty pants, is there a similar something that works for stuff that's not normally distributed? Yes, there is, and it's called Chebyshev. Do we talk about it in AP? That's a guy's name. It's just called Chebyshev. Chebyshev? It's C-H-E-B-E-B-S, or Chebyshev. Of course, the mathematician does not have an easy name. It's called Chebyshev's rule because he came up with it. However, it's not something we're going to discuss in here because it's not something that you have to talk about in AP Stats. It's not something you have to talk about in AP Stats. Okay, so 2 days ago, we talked about something called a Z-score. And we didn't really use it. Today we're going to use it and see why it's useful. Maybe more useful than that empirical rule. Okay, and then one more thing I wanted to tell you about that I forgot to mention yesterday that your book reminded me of. You need to get used to this notation. The N in this is standing for normal. What is the mu? The mean, and then this symbol? Yeah, Megan? Ooh.
Sampler population.
It's actually going to stand for standard deviation in that case. Now, were you supposed to guess that last one? Probably not. But again, all that we're doing with this empirical rule, this 68, 95, 99.7, it only works if our data is normal. And if our data was normal, would we pick the mean or the median?
Median.
I mean, it wouldn't matter. They'd do the same thing, but we pick the mean, which means we would pick the standard deviation. It's when we have that skewed data that we would rather look at the IQR and the median. Yes, I graded your test. Yes, some people still don't understand that. I'm praying we get that over with soon. Okay. Words. When I have a dot plot like this, or a histogram or whatever, and I apply my curve to the top of it, what is that called?
Density curve.
A density curve. When you add your curve on top to try to make it beautiful, you've made a density curve. You do.
Where's that thing? There it is.
Now, Jackson pointed out something smart yesterday that I would again point out today. Technically, and I'm going to use my pencil because I'm going to erase in a second. Technically, if we drew a line down where we think that middle is, technically, shouldn't 50% happen to the left of that line and 50% happen to the right of that line? I mean, technically, theoretically in life, that's how life's supposed to go. You find the middle, half's 50, the other half's the other 50. He said that yesterday, and I don't know if everyone else heard that, so I wanted to point that out. It's a good thought. Okay, now as for the problem we were too chicken to handle yesterday. I don't know why we're so stuck on baseball. Okay, in 2010, the distribution of batting averages for Major League Baseball players was approximately normal. Those are key words. We have to see those words. That means that we have this normalized bell curve, this mounded shape. Otherwise, if they don't say the words normal, standardized, symmetrical, they don't say something about how it's beautiful, we can't assume that it is. Okay, and then it tells us specifically we have a mean of 261, or 0.261, it's cut off on my paper. 0.261. And a standard deviation of 0.034. They say, can you sketch this distribution, labeling the mean and the points 1, 2, and 3 standard deviations away from the mean? Okay. So let's look at our picture. The mean is at 0.261. The little markings are going up. Let's see, 2.5, so that'd be 2.6, 2.7, 2.8, 2.9. So 2.61 is going to be a little bit above 2.6. So let's say this is 2.61, somewhere in here. No, mine's not perfect. My bad. And they ask for us to go the 3 standard deviations away. So I need to add 0.034 to figure out 1 standard deviation above. And what do you get?
What?
You add our mean plus 1 standard deviation. What do you get?
0.295.
Yes, and we're just going to go ahead and round up and say that's 0.3, but 0.295 is correct. But it's kind of hard to find 0.295 on this graph, so we're just going to say it's 0.3. And that's 1 standard deviation above. That's a 1. We need to do the same thing, and we'll mark it in just a second. We need to do the same thing and find 2 standard deviations, and we need to find 3 standard deviations. So why don't we just take our previous answer, that 0.3, and add that standard deviation, 0.034, and we would get
0.329.
and we're just going to say that's 0.33. We're going to approximate that on that one again to 2 decimal places. Specifically because of how my graph is drawn, I don't think you and I are good enough to get 3 decimals. Okay, and then 3 standard deviations, we're going to take again that same number, so 0.33. So we found 1 standard deviation, it was this number. We added another standard deviation, it's this number. Now we need to add 1 more standard deviation, and we would know 3 standard deviations away from the mean.
Do we need to do it in the minus direction as well?
Oh yeah, we're going to. Oh yeah, we're totally going to.
Isn't it 0.034?
How did you get 0.034?
Isn't that another standard deviation?
Oh, I didn't add the 0, yes.
So that would be like 0.3.
It's 363, I believe. I was hoping someone else would confirm I'm not crazy today. Louise, did you get 0.36?
Yes.
Is it 36 or 35? Is my rounding wrong?
3.6.
Okay.
3.61.
It's 3.6 or 3.5. We're really not being that picky today. Maybe we will in our future lives. Again, I'm always in a hurry. I need to slow down one day in my life. Okay, so 1 standard deviation was 0.3. So let's mark it. This was the 1 standard deviation mark. Two standard deviations, we said that was 0.329, so we said that was 0.33. So 3.1, 3.2, 3.3. So we're going to say this is 2 standard deviations. And I might even write the number underneath just because I want to help myself so I don't have to keep looking back over here at my other numbers. Yes, dear?
Okay, so I know that there's a percentage on the things to Chebyshev, but are we ever going to have to work out a problem the same way where we find the first standard deviation, second, and third for a non-uniform,
Normalized? No. No.
We don't have to do that?
No, in fact, it's like you're already on example 5. Well, no, it's still normal then. If it's not normal, we can't do this.
Okay.
Okay.
Oh, because that would make sense, because you can't equally standardly deviate out if it's not standardized.
Yeah, if it's skewed one way or the other, then 1 standard deviation out is actually not going to be the same on each side. Yes, very good point. Okay, and then the third standard deviation would be 0.36, and that's the third standard deviation. Okay, and yeah, that was good enough for a point. Okay, so does everyone understand my math on how to find the 3 standard deviations away on the right?
So you're just adding, you're just going on from what you got the last one.
Yeah. So I did mean plus 1 standard deviation, took that answer, add another standard deviation, took that answer, add another standard deviation.
Yep, got it.
Could you have made it your life more complicated and done the mean and then plus 3 times your standard deviation to find that third standard deviation away to begin with? Well, yeah. But we were trying to keep our life simple, so we didn't. Okay, I think Mackenzie asked a good question. Are we just going to do it on the right? No, of course we're going to do it on the left side too. Of course we are. So same math. Well, no, it's not the same math. We're going to take the 0.261 and subtract our standard deviation. And we need that number. And we have to find the 2 and the 3 as well.
Can you just get over just a little?
Yes. Okay, so we found 1 standard, 2 standard, 3 standard deviations above the mean. Now we have to find 1, 2, and 3 below the mean. So I took my mean, I'm subtracting 1 standard deviation, and I need to know that number.
.22.
It's 0.227, and I'm just going to say that's 0.23. Am I doing a good job rounding? We pray.
You do your best.
Yeah, I'm doing the best that I think I can for this graph.
That's what I've got.
So this is, thank you.
Point.
That's 1 standard deviation away. No, I'm not. Okay, and then for 2 standards away, I'm going to take 0.23, my previous answer, and subtract off that 0.034. Would it be better in life if Louise, he's using his calculator, right?
Yeah.
He gets Miss Compton's just writing stuff down so people knows what the crap she's doing, right? His calculator already has it stored as 0.227. Wouldn't it be better for him to keep going with the calculator approximated value rather than his rounded value?
Yes.
Yes. So if your calculator was 0.227, then please keep the 0.227 minus 0.034 for the next.
Oh, so now this side of it is the difference is the other way. We got one here, subtract 0.9.
And I'm going to say the 0.19. So there's 2 standard deviations away. And now I've got to do that last. So I'm going to take another standard deviation off. So take your number, subtract 0.034, and you get,
0.15.
and I'm going to say that's 1/6. So here's my third standard deviation. And it's getting all ugly and colorful up there, let me tell you.
And if you're batting like that, you probably shouldn't be playing Major League Baseball.
You know, if you're batting this poorly, you probably shouldn't be. Do we really expect batting averages to follow this kind of distribution? Probably not. But what we're going to learn, and what's moral to all the stories in AB Stats, is if you take enough samples and have a large enough sample size, everything tends to be normal. As long as your sample size is large enough. Okay, so now we've got some questions to answer, which sadly has nothing to do with all the hard work we just did. Well, it's kind of, but not really. Okay, you already know this answer. What percentage of players have batting averages within 1 standard deviation of the mean?
68.
Within 2,
95.
and then within 3.
99.7.
I want some 97.9.
Oh, God. Okay. Now that we've got some more decimals, and look, they're being more precise than we were, so maybe we should have stayed with 3 decimal places. Hindsight's 20/20. Okay, what percent of batting averages have a batting average greater than 0.295?
16%.
And how are you figuring that out?
Yeah, because you just remembering from yesterday that if it limits it to this thing and above, and it's just 2 lines left, 16.
Because it would be 50%, and then half of 1 standard deviation, 68%, get 34, so 84%, right? It's not 16%.
Yes, I was just going to do 100 minus 68 and then divide it by 2.
Yeah, I guess you could do that.
Okay, so for those of us in English,
Yeah.
Yes, please.
let's get the highlighter.
There's that.
Oh, good. That'll make such a difference.
Let's see. For those of us in English, We've seen 0.295 earlier. We saw it already when we were doing these calculations. Yay, us already doing all the hard work. 0.295 was 1 standard deviation away, yes?
Yes.
So if I go to here, how much was supposed to fall within 1 standard deviation of the mean? Okay, so 68%. So how much is outside that 68%?
32%.
32. So you and I took 100%. We minus 68 and we got 32, yes? But we're only talking about, they just want to know for just this side. So do we really want the full 32? We want half the 32.
Oh,
What's half of 32?
That's like when we were looking at the printout that you got from me because it's patterned, not colors.
Yes.
It's cool, it's just that side.
Yes. What would just this side be? And it would be 16%. Okay, so again, the middle 1 standard deviation away was 68%. So each tail added up to those 32. So one tail was 16, one tail was 16. We only want the one tail because it said had a batting average above this. And can you believe it? The next question is probably along those same lines of had a batting average below. And I'm betting they're doing the same thing.
It is the same thing. It's just-
You know, 1 standard deviation below, so it's just, what was it from here down? So it's the other tail of that 16%.
So we just write 16%.
Just write 16% again.
The next one, the next
I never said we weren't repetitive sometimes.
Is the next one 2.5?
Absolutely.
Cool.
Okay, so yesterday, I forgot it was someone in this group that said, I think that was McKinsey, but I keep trying to give McKinsey credit for things that aren't necessarily hers. Okay, so batting average 0.329. You and I just figured out 2 standard deviations away was about 0.329. So we're wanting to know from here on up how many people had that. What percentage is within 2 standard deviations of the mean? What?
96.
Woo!
95.
So we have 95% within 2 standard deviations of the mean. So we have 5% for each tail. Yes? So how much would just one tail be? 2.5.
We always talked about that yesterday.
We did. But you slept since then, and this is important, so we can re-stress it again.
I wasn't criticizing.
No. Okay, and then same thing's happening over here, and they ask how many are below, but they're still asking for below that the standard deviation to the left, or below. And we're still going to end up getting 2.5, because they're wanting to know still about the blue tail, but they want to know the left blue tail rather than the right blue tail.
Ooh, the next one.
And then the next one is where life gets fun. Yes, dear?
Is it 13?
It is 13.5. Okay, you do get a point for that.
And the other tables who got that right get a point for that.
You know what? You had the 16 first, so you can have a point for that.
Okay. You get a point.
Everybody.
I'm telling you, everybody is, and you know, it's not like Jared, Ashley, and Jane aren't in math class. Eventually they're going to say something, or I'm going to skew everybody's points. It is what it is.
We don't need skewed points.
Oh,
They're
no.
skewed right, Leon.
Okay. That's so true. Okay, so it says how many is between 0.295, let's find that, 0.295 and 0.329. So they're asking for how many are between really 1 standard deviation and 2 standard deviations. And didn't you and I just calculate this yesterday?
Yes.
That 95 minus 68 was what?
Mm-hmm.
What was 95 minus 68?
It was 27.
Oh, thank God, someone with math. Okay, 27, and then divide that by 2, and you get,
13.5.
and that's how we got that 13.5. So again, Mackenzie was asking me yesterday, should I go ahead and just memorize all these numbers?
I just remember.
No, you shouldn't. If you remember, Lord knows I'm going to throw so many numbers at Louise. I need him to have, whatever his name is, I need him to know 68, 95, 99.7. He's smart enough he can figure out the rest.
Sure.
Theoretically. Okay, 34% of players had a batting average between what and what?
So 0.261 and 0.295? Or you get the lower ones to be.
I did the lower ones.
Okay, so then it'd be 0. The other one.
What is the other
I
one?
forgot. This one, okay, so it'd be 0.23. Whatever it was.
0.23.
Yeah. 0.2.
I think it was 227, but 23 is what we rounded to, yes.
Where are you getting those numbers from?
Oh, we're going to talk about it in just a second. They're just showing off so they can get their point.
It's the 68% and divided by 2.
Yeah. Yes.
What?
My favorite pumpkin.
Oh, boy.
Mr. Furman.
I just talked about you earlier.
Yeah.
Good. Yeah. Hey, figure out the next answer. Let me talk to Mr. Warren. He's like the
Your
best.
name's right
You're
there.
not loving it.
Yeah,
Yeah.
it's in the
He said,
corner.
hey, why is the name still in here? I was like, I don't know.
The barcode.
Yeah, 'cause it's
What, the barcode for me?
Oh, there it is.
I read
That's
it
it.
on this morning. I was embarrassed.
Really?
Yeah, the copier with you.
Does anyone in this classroom have food?
I have food, and then I use it. Dang it. So we're having outside practice, so I ate today, because I thought I was
And now we're there. Well, I don't know about that.
It's not raining.
It's not raining.
You know she doesn't.
You already said the next
We were in the same day. Oh, you need to
No,
say.
What good old Western Esther said we had to
they canceled the ball.
Western Esther. Esther Wesley. Esther
I think
Wesley.
even Nutcracker, the arms work with this teacher.
Well, what were you crunching earlier? Someone treated your team. Who was that? Oh.
I only ate exclusively cereals myself. That's it.
I will. Okay. Did someone explain to them how they got this, or I need to come up with it?
Or you do.
I know the next thing.
You know the next answer, but do I need to explain this to somebody?
I have a
I
question.
Um,
think we're good.
Yes, I got one yes. So let me back up to life. I got so excited. Okay,
Straight out of Compton.
I know. We had yes.
I awarded a point to this team because they gave me a peppermint. They were nice.
We can give them a point. Plus, they're just so darn good and quiet. My gosh, we're gonna talk them into talking one day. Okay, back to the color scheme. So they asked for 34%. They said something. 34% of players had a batting average between. So we could have picked either between the 0 and the lower standard deviation, or what Louise wanted to do, and it doesn't matter. It's just what my key had. It doesn't matter. We could have done the other between 0 and the upper standard deviation, 1 standard deviation. But we didn't. We did the other way. So that's why we said 0.227 for the lower and 0.261 for the upper. But we could have done 0.261 and then 0.295. It didn't matter. It's just back to, if you're remembering the 68, the 95, and the 99.7, 68 divided by 2 is 34. So they're just talking about one piece of that 68.
Can I answer the next one?
I know, you're so excited, yeah.
Already answered it.
But really, I think technically I answered it to begin with, but yeah, you can answer it.
0.261.
Okay, so back to, no, this is rather obvious, but when they say 50%, where was that middle mark? Oh, it was the mean, so give me the mean. It is very possible that they can do that to you. Okay, and then this is where life goes haywire. So, that was fun. 68, 95, 99.7, they're great, they're terrific. And if life is good and they ask you about 1, 2, 3 standard deviations away from mean, that's always going to work. What are we going to do if they ask us about 1.5?
You
Or-
go all the way up to the 4 standard deviation.
Or what if they ask us about 4? We didn't talk about a rule with 4. Or what if they ask about 2.75 standard deviations away from mean? What if they don't ask the 1, the 2, the 3? What if they're not talking about the 68, the 95, or the 99.7? Then what do we do?
Math it.
So part of me is like, maybe if I just take the middle, and I was trying to do that earlier, I was like, well, average of 68 and 95, and if I find the middle of that, is that going to work? And it actually, for 1.5,
Yeah, on the other
so I was trying to like, since 1.5 was in between 1 and 2, I was like, could it be in between 68 and 95%?
Do you just,
You mean 2.5?
Huh?
You mean 2.5? Where's the 1.5?
do you
I'm just making it up.
Oh.
Like, what if they asked me 1.5? Then would I average between the 1 and the 2?
Oh, okay.
And if they asked me 2.5, would I average between the 2 and the 3? Like, deep thoughts. And guess what? Doesn't work. Doesn't work for 1, 2, or 3. It only works for 1, 2, or 3. It doesn't work for anything else. That's why we have a backup plan, and that's why we're coming back to these scores. Yes, dear, you had a question.
I was just gonna say, could we like multiply the standard deviation by like 2.75?
I keep trying to make life that easy, and it's not. If they don't ask for the 1, 2, or 3, then we're not talking about the 68 and the 95 or the 91.7, and we've got to have a different attack mode. So, moving on to our next example, which is really sad. So, yeah, we've done 2 examples today. So, moving on to our next example. When we can't pinpoint it just instantly, we've got to have a backup plan. And here's when we're going to figure out why we need a backup plan. Okay, so example 5. Suppose that a distribution of test scores is, there's those key words again, approximately normal.
Which means good.
Good, so we can try. We can use the mean and we can try to use this rule. Which means good. Okay. Oh, yeah. So it's the middle 95% of scores are between 72 and 84. Okay. So if you want a point, what's the mean then? And that's how you get a point.
We already know,
Gotcha, guys. Sigma equals 3.
God bless you. I'm just going to put SD, standard deviation, for the rest of us. God bless you. You can have another point for that.
Yeah.
Okay, so let's talk math. So they said the middle 95% were between 72 and 84, meaning, hey, if we were to draw our own little curve real fast, we can totally do this. 95% is how many standard deviations away from the mean? 2, agreed. So we're talking, and we know that the lower of this is 72 and the higher is 84. He's smart enough that he added 72 plus 84. He divided by 2. The middle of that is 78. Which means...
the median and the first 2, or the second standard deviation first.
Yeah, so we just have to figure out the 1 standard deviation away. But hey, we're kind of smart. We know there's this pattern going on.
Just take the median and then one of the second standard deviations and then find their middle point.
Or we could, he's completely correct, and if this was harder math, we would. But you and I know between 2 and 8, there's 6, right?
Yeah.
What's 6 divided by 2?
3.
So 72 plus 3 is 75. 78 plus 3 is going to be 78, 89, 80, 81. 81 plus 3 is 8. Yeah, you can have a point for having deep thoughts.
We've done every point today.
Okay, so again, we found, they told us 2 deviations out. We're smart enough that we figured out the mean, and then once we knew the mean, like Jackson is talking about, we can somehow figure out 1 standard deviation out. We're that good. Okay, so yeah, everything's working great. That 68, 95, 91.7 worked great for part A. And then we get to part B. And now we've got a problem. Because they asked for the percent of scores that are above 80. And 80 is not quite 1 standard deviation away from the mean. And it's definitely not 2.
Can't put you guess.
Yeah?
25%.
You're hurting yourself.
Jackson's point away.
Yeah, take it away. 5.
You hurt yourself.
Okay, Louise, ask how you think you should do
Give us the
this.
grade for all of us, right?
For 1, I'm going to place my guess as 25%. Is it 25%?
You were such a thought.
Can I get a point for that? Can I get 2 points for that?
How did you figure that out?
Well, it's like an exponential curve, and so that one has to be 16. I just assumed that the next unit over would have to be 25 as it curves upwards. Also, because you use the z-score, and you found...
Give them 8.
That's what we're going to do. That's what we're going to do.
Okay.
Okay. That's Earth. That's Earth. Welcome back to Earth.
How many points
Okay.
did you get for that?
1.
Dang it!
1. Okay,
That's
so...
worth more than 1 point.
No, it is not worth more than 1. Because I already told you we were doing z-score today, so if you already realized eventually he needed to use the z-score, how dare he use context clues? Okay, so, talking about the curve and okay, that was cool, but that's how he got the 1. Okay, so 80 is kind of annoying because it's not 81. If they had asked for 81, we would know the answer. But darn it, they asked for 80. So they're asking for how many are above the 80, and we need to figure this out, and we can't use our handy-dandy new little trick. So I'm going to put yes, we can find this out, clearly, because he already knows the answer, but not with and do you remember the name of the rule?
Empirical rule.
It's called the empirical rule. Do you have to know the name? Heck no, it's not points for that. If you know it is 68, 95, and 91.7, you'll be fine.
Can I get a point for
No. The next one who asks for a point is going to get a point. Yes, but not with the empirical rule. So we've got to use something else. I need to use z-scores. Okay. So let's talk about z-scores. Again, Jackson's right. Everything's beautiful when life says standardized and normal. If it doesn't say standardized, approximately normal, we're not going to be able to use any of the things we've been using. But since it did say approximately normal to begin with, we are going to get to use a z-score. Now, I don't think I did an adequate job yesterday. Put it down. I got to say words. I don't think I did an adequate job yesterday. A z-score ends up making everything approximately normal. And we assume that the mean is 0, and that everything is 1, 2, 3. Like we're assuming the mean is 0 when we standardized it and made everything into zeros and ones. I don't know if I explained that or not. Your textbook does a good job of explaining z-scores better if you want to see that. What you need to get out right now is your formula sheet. I gave you a 7-page formula thing. If you're going to do it, you need to get it out. Okay, now your calculator can calculate a z-score, and we'll figure that out tomorrow, or not figure it out, I'll show you that tomorrow, but it's more important to me that you're able to read the table. So if you're looking at your packet, hey look, you know that standard deviation, so moving on. So many things to move on to. So we see that there are 2 tables that say z-scores. And what stinks is they're not filled in well. I swear they're filled in better on the exam. Darn copier doesn't copy things exactly like I want it to. So this one should be filled in. Let's see. This one was filled in on the left. Okay, so we're going to reference this in half a second. So have yours out and ready to go. Okay. So in order to use our handy-dandy table from our formula sheet, we're going to first have to calculate the z-score. We had a formula 2 days ago for z-score. We need to find the z-score for 80. What was the formula for z-score? Okay. And for us, what they're wanting to know is 80. Our x bar is our average, so it's 78. The S is the standard deviation, so it's going to be 3. So it's going to be 2 over 3. I actually need that decimal. What is that decimal? And I'm going to need it to 2 decimal places in order to read my z-chart. Okay, so we need the 2 decimal places in order to actually read this table accurately. So first what we did is we converted our data to a z-score. That was our step 1. We converted it. Our second step is now going to be either to use the table or we could use our calculator. To find the area. Okay, so we want 0.67. So let's go and look at our table. I'm looking at the one with the positive z numbers. And as I look, and I'm going to write on mine because I'm going to erase it with my pencil, I see 0.6. Everyone sees the 0.6?
Yes.
And so for 0.67, I've got to come over here to 0.67. Does everyone understand how I knew that was 0.67? Okay, again, 0.6, I knew it was somewhere on this row. Since I wanted 0.67, I'm going to go to 0.7486. Okay. Yes, dear?
How did people find these numbers?
Back to that Pythagoras thing of they've done so many problems and these kept on happening. So they just made you a useful table so you don't have to go through the pain and agony.
Well, why do they have to go?
This is a lot of pain and agony.
Yeah, so many. Too deep, Mackenzie. Too deep, Mackenzie. As soon as the AP exam is over, we can have the most fun you've ever had in your life.
Calculus.
Huh?
More M&M lines?
Yeah, there's another M&M Labs with normal distribution. I just hadn't done it yet. Okay, so does everyone understand how I got the 0.7486?
Yes.
But there is a problem. So let's go back to our problem. Let's look at, God bless you, bitch. Okay, so let's look at ours, and let's see where we've highlighted that we need, right? Now look back at that table. Were they shading to the right?
No.
They shaded to the left. So 0.7486 is something we need to use, but we need this part over here. So instead of using 0.7486, we have to do 1 minus 0.7486 in order to figure out this mystery remaining. So back to what I didn't say yesterday, 1 minus 0.7486 is going to be like 0.2 something like that.
0.2541.
Thank you.
0.2514.
I think it's 2513.
It's 2514.
Oh, okay. I can't do math. Cool. So I can't write either. Great. Okay, so let me say those words again, because even your book says, like, or at least it tells me, hey, tip, common error. Common error people make on the AP exam. They're so excited that they converted to a Z-score and that they went to their table and found their number that they automatically assume that's the answer, and they don't pay attention to, is that the region I needed? No, we needed the opposite region, hence why we're going to do 1 minus that number. Because back to a Z-score, and I guess I didn't do a good job of saying that, or I think I did in my notes.
You did.
They always have a value of 1. The curves do. The density curve. It's always going to add up to 1. Once this Z perfect world, it's always going to add to 1. I swear I said that the other day, but I might not have. I think I say a lot of things that I don't actually say. Okay, so our answer, we wanted to say was 0.7486, but it's not. It's actually the 0.2513, or 2514. That is our answer. So can we calculate the percentage of scores above an 80? Yeah, it's 25.14%. And when they say explain, my God, you better have this. Okay, so that is the best question anyone's had today, and here's why. There are some in the room who do all the math of the world and don't put any words. And then there are some that put too many words, because as I learned at training, too many words, you tend to start looking stupid, because you tend to say, like, roughly, I don't know, you start saying things that are wrong. Too few words, and you've got a problem, because, let's face it, if we don't actually explain what this is, they're not psychic. They don't know what you did. So should I maybe say I converted my data to a Z-score? I converted my data to a Z-score. I used the table to find the area, and then to find the area under the curve. And then say the percentage of scores above an 80 are 25.14. Probably so. And then, you know what? I didn't do a good job in my answer. What did I not reference well? Yeah, so if we don't actually throw in some, this is baseball, then technically we've not made it relevant, and we got us a problem.
It's not baseball. Stat scores.
Stat scores, whatever we're doing. Treat. Middle name as test scores. Yes, I can't read. Okay, cool. That's beautiful. I'm gonna steal that right now. So seriously, just Sally throwing in the 2 words test scores means she's related it back to the content. And when we're grading stuff on the AP exam, you can get 50% more points just by relating crap back to the content. If you don't relate it back to what it was, like this is an outlier because, or like she said, 25.1% of the test scores are above an 80, then they don't think you know what you're talking about. Okay, so let's look back. Do you have homework you ought to be working on? Let's be honest. You're supposed to be for this chapter. Okay. You also are going to get a coloring page tomorrow. That's going to be your homework over the weekend. Now, I say it's a coloring page, but you have to do math to then color. So, okay. I've tried to make it fun. Color. Oh, you don't have to color. You just have to do the math.
Yeah.
So, is it points in the math? Like, no, yes.
For me, no. For the rest of you, yes.
Okay. Okay.
If you were to like lose a point somewhere else, would I probably feel sorry for you after you spend all that time coloring? That tends to be what happens. I'm like, bless her heart, she went 20 minutes coloring, she missed the one problem, she gets perfect score.
The answer to the problem?
Yes.
Well,
It just makes it easier to grade. He doesn't have to color.
Okay.
It just makes it easier to grade. I just look, did Sally color purple where she was supposed to color purple? Yes, no. Like, it makes it easy to grade. If she doesn't do it, I'm going to look at her work anyway. Not a big deal. I forgot what words I was saying. Okay, you can put up your notes. Let's look at your test, those who actually took it. And the one who didn't can still hear the words.
I still have to finish.
Oh,
You can still hear the words.
I can still do it?